Hello class, welcome back to another lecture. Today we will be talking about water chemistry, which fun fact, it might be my most favorite part about all of science. So we have a fun crash course video to help us learn about water chemistry. Again, I think this will uh, be not only a good way to hear someone else's interpretation of water chemistry or maybe how someone else might explain it or talk about it, but it helps us, well, frankly, it gives you a break from hearing my voice so much. But I will leave a link to that in our classroom, so please pause this video now and go watch the awesome water liquid awesome crash course. So before we get started, we're going to talk about some vocab as we start every lecture or every new unit, every new lecture. So let's start by talking about some vocab. So important things to talk about are a hydrogen bond. This is something that you probably should have learned last year, but I understand it was in Spanish. So we're going to go over again in English. So a hydrogen bond is an attractive interaction which occurs when an electronegative atom bonds to a hydrogen atom. I'll have some better examples later on, and I think our video from Crash Course just talked about hydrogen bonding. So we'll get some more work with that. We'll talk about cohesion, which is the state of smaller molecules sticking together. Sorry, similar molecules, not smaller. State of similar molecules sticking together. And then adhesion, which is the state of different molecules sticking together. We have a few more words. We're going to be talking about hydrophobic. Hydrophobic literally means water fearing, and hydrophilic means water loving. So hydro, our root is hydro means water, and phobic means to fear. Philic means to love. The last thing we're going to talk about is our heat capacity, which is the ratio of heat absorbed to temperature increase. Heat ratio is an important chemical property when we're talking about different liquids or even just different solids or gases, just how much heat or energy can be absorbed without it raising its temperature. So hydrogen bonding we're going to get into. So an oxygen is more electronegative, so it pulls these electrons closer than the hydrogen atoms have. So this big red part is our oxygen molecule, and these little white circles are the hydrogen atoms. So H2O. So we have two hydrogens and an oxygen. This oxygen likes electrons a lot more and is a lot bigger, so it will pull these little hydrogens closer to it. That means that since this hydrogen now has the electrons closer, now that this oxygen now has the electrons closer to it, it is more negative because electrons have a negative charge. So the closer they are to you, the more negative you are. And that means that since our hydrogen atom has lost some of its electrons, it is more positive. This is called a partial bond. Yep, so this causes a partial negative charge on the oxygen, a partial positive on the hydrogen. So this happens in every single water molecule. And then these water molecules can come together to form a hydrogen bond. So this partial positive charge on the hydrogen part of this water molecule will combine with a partial negative on this oxygen atom to form a hydrogen bond. These hydrogen bonds are not like other chemical bonds. They are much weaker than other chemical bonds, but they still do have some energy trapped in them. So this is why when heated up, this is why water has a high heat capacity, I should say, because when you heat up water, it takes a really long time because it takes a lot of energy to raise the temperature of your water. So if anyone has ever tried to cook pasta and needs to boil water, it usually takes a while because we have to break every single one of these hydrogen bonds so that the water molecules can be released and go into the gas stage from the liquid stage. So Hydrogen bonding also leads to a high surface tension of water, which is really cool. It allows a lot of insects and even some animals to walk on water, like this little lizard can do. But we can see different insects literally just sitting on top of the water, and even one Jesus at one point to walk on water. So also, this high surface tension has an interesting fact that if we're falling from a high enough point and hit water, it will act as if we were hitting concrete. So it creates this very tough barrier to break. And then if we are falling, then it could be fatal. So some interesting facts. Now, combining our cohesion and adhesion, we can create a capillary action. So we're going to define what capillary action would be. So it's liquid flowing through a narrow tube or even just a porous area. So a narrow tube usually against gravity or often against gravity. So this is what happens thanks to cohesion and adhesion. It's super important for many processes, but especially like in life, like plants. For example, the water that is used to grow plants gets used in the leaves, but we don't water the leaves of the plant, we water the roots. And then once the roots are able to absorb the water, they put them into small tubes, and then the water can climb just like it does in this little video. We're going to watch this water climb up a brick. You can see it getting darker as it goes higher and higher up our brick. It does the same thing. It can climb against gravity, which does not make sense at first sight, but after understanding our cohesion and adhesion and capillary action, we understand how it works. So the other important thing that comes with water is it's known as a universal solvent. It can dissolve a lot of things, so we'll talk about what a solvent is. So first, solutions are made of solvents and solutes. This most commonly occurs with liquids, but it can be in gases or, wow, that should say or solids, not or liquids, but it can be in gases or solids. Our solutes are the substances being dissolved in the solvent, and our solvent is a substance that dissolves a solute. So, for example, I think it makes the most sense is when we have salt as our solute, we put it in water, which is our solvent, and make a solution known as salt water. Some solution examples you might be aware of are soda. So the carbon dioxide in soda is the solute, while the soda is being the solvent. So the reason why soda or Fresca has carbonation in it, and if you shake it will kind of flow, like foam up and flow out of the cap, is because it has that carbon dioxide dissolved in it. We also have shots at the doctor. Our shots has medicine as our solute, and then the water is the solvent. Then that allows the medicine to go into our bodies easily and then get into our immune system and help us. So what other examples can you think of? I encourage you guys to pause the video and even just jot down a few ideas of maybe some solutions that you might know besides salt water, soda, or even shots at the doctor. They're a very common thing that we can see. Then we're going to talk a little bit closer about salt in water and the chemistry behind it. So if we can remember just a little bit back to the beginning of our lecture, we talked about how each water molecule has a partial negative on our oxygen and a partial positive on our hydrogen. So we should know that our opposite charges like to attract. So our positives like to go to our negatives and our negatives like to go to our positives. So in salt, which is NaCl, our compound of salt has two elements, sodium and chloride, which like to separate into a sodium ion and a chloride ion when in water. So then once they are separated, these partial charges on the water bond with each element. So for example, we have our partially positive hydrogen, surround our negatively charged chloride element, and our partially negative oxygen surround our positively charged sodium ion. So our fun fact of the day is when we're adding salt like this, or really any kind of salt, to water, it raises the boiling point and the melting point. So if we put salt in our water to cook our nice pasta, not only does it make our pasta taste better, but it raises our boiling point so that instead of water boiling at 100 degrees Celsius, it'll be above 100 degrees. So it will cook our pasta at a higher temperature and it will cook it quicker. The same thing works for melting point. So where I'm from, it's in Wyoming, in the United States, it snows a lot. So because it snows so much, when there's ice and snow on the roads, they'll go and put salt down. So the salt will combine with the snow, which is filled with water, or the ice, which has some water in it, and then raise the melting point so that the roads can get cleared of the snow and ice quicker. So, fun water chemistry. If you guys have any other questions, let me know. We're all finished up for today. I hope that it was clear, and if you have any questions, please let me know.